I'm pouring the unknown solution into the beaker. Now I'm going to add the 10 drops of ammonia. I'm going to dilute my solution with water. Now we're going to check my cloudiness and then keep adding the water. Now I'm going to invert my solution several times. I'm going to transfer my solution to the beaker so we can add it to the beaker. So I'm going to take my prime pipette and suck 5 milliliters of my unknown solution and put it into the volumetric glass. Now I'm going to transfer the 0.01 molarity dilution into the cup.
Hi, that's time. Can you make that?
When looking at the relationship between absorbance and concentration, we find that as the concentration rises, the more light is absorbed, therefore increasing the absorbance rate. When using the spectrophotometer, you have to wipe down the sides of the cuvette, place it in at 0 at first, so you are starting on a base level. If you do not zero or clean the sides of the cuvette, then you are skewing the results by changing the absorbance rate given off from the cuvette. Lambda max is the wavelength at which a substance has its strongest photon absorption. Lambda max is determined by plotting absorption versus wavelength and noting where the sample absorbs the most light, which is why it is necessary to collect absorbance data at different wavelengths.
Chem light. Then I'm going to place it in the spectrophotometer, closing it. Over here, I'm gonna hit read. Okay, and we get 1.035.
You can save it as whatever you want as long as it's not inappropriate and we can remember. Okay. So
First I don't press.
don't press start. Just you all know what to do with like zeroing and then
Stopped it. Go ahead.
that just basically says zero. If you that's like that is why. That is why. Because basically when you did this and you can zero with that and then the other one.
I just think you want to look at this thing first. You said it? I think as long as it's zero.
Don't rush these things, just.
Beer-Lambert's law states that there is a linear relationship between absorbance and the concentration of a sample. The equation is A equals epsilon LC. A equals the measure of absorbance, epsilon equals molar extinction of coefficient or the molar absorbency, L equals path length, and C equals concentration. Epsilon is a constant and varies for each molecule. Units are in L times mole to the -1 times centimeters to the -1. L is in centimeters and is always assumed to be 1 centimeter, and you solve for C.
Should I start? Yeah?